Lab 1, which was about charged tapes. So the purpose of this lab was to analyze how two pieces of charged tape interact with each other and other objects. Also, to understand how to find a certain amount of excess charge on a charged tape. So this is a model. The top picture is a model of a second component of the lab, which was taking two pieces of tape and putting a certain distance in between them in order to observe the electric forces and the behavior of the forces. And here's the actual picture. The bottom is an actual picture of the lab. So the fundamental principles and ideas used in this lab were the Coulomb's law and the Newton's second law. The result of the lab were positively charged U-tape was attracted to a charged plastic pen. Negatively charged U-tape was repelled away from a charged plastic pen. A neutral U-tape was attracted to a charged plastic pen. The charge on tape B is 1.22 times 10 to the negative 9 coulombs. Tape B was missing 7.6 times 10 to the negative 9 electrons. Some of the observations and assumptions that were made were two U-tapes repelled each other, and two U-tapes are attracted to neutral objects. And some assumptions that were made, which could cause potential errors, are ignoring air resistance on a moving object, treating a long tape as though it were a point charge, with all the charge concentrated at the center of the long tape. Also assuming that each U-tape that was in the experiment, assuming they had the same amount of charge evenly distributed along the length of the tape. These were some assumptions that were made. Now the calculations. First, the gravitational force needed to be found using F equals m times the gravitational acceleration. The gravitational force of a tape B was 8.33 times 10 to the negative 4 newtons. The distance between tape B and A was 0.004 meters. This is the required distance in order for tape B to float. Now, using that information, the charge on tape B, utilizing the idea that the gravitational force had to be equivalent to the electric force, and using the formula, rearranging the formula, 1.22 times 10 to the negative 9 coulombs was the answer that was found, and that was the charge on tape B. Now, to find the number of deficient electrons, or the amount of electrons that are missing on tape B, divide the total charge by the charge of an electron. The answer to that is derived as 7.6 times 10 to the 9 electrons. This is the amount of electrons that were missing. Now, in order to find the number of atoms on the sticky surface of tape B, we would have to take the area of tape B, divide that by the area of the atom, and you would get 1.7 times 10 to the 17 atoms. And now, in order to find the ratio of the number of deficient electrons to the number of atoms on the sticky surface of tape B, we would have to take the amount of electrons that were missing and divide that by the amount of atoms on the sticky surface of tape B, and you would get 4.47 times 10 to the negative 8 atoms. And tape B is the system in this experiment, and tape A is the surroundings. And so the answer to these questions, so the answer to the first question would be, their charges were flipped. A charged tape would still be attracted to neutral objects. Additionally, two U-tapes would still be repelled from each other because they would still have the same type of charge. And the answer to the second question would be, when charged tapes come into contact with someone's hands or other objects, it causes the electrons to flow into the tape or out of the tape. This could potentially cause the magnitude of the charge of that object to change, or it could cause the object to become neutral. And to conclude this, overall this lab helps build our overall knowledge on charged objects and some of their characteristics, such as the electric force they produce on each other.